Okay, let's dive right into this explainer. Today we're exploring how to build something absolutely revolutionary, an intelligent, financially settled communication network that runs entirely off the traditional grid. We live in a world that's getting more and more reliant on centralized infrastructure, and frankly, that infrastructure can be pretty fragile. So we're going to break down the source material to see how stacking four very specific technologies together, Mestastic, Gemma 4, MQTT, and Saito, can create a genuinely self-sustaining, sovereign internet. Let's get into it.
So picture this. Disaster strikes. Maybe it's extreme weather, a massive power grid failure, or centralized cellular networks just completely crashing. Our modern ability to communicate, to transact, to organize, it all just vanishes. The core challenge we're tackling today is figuring out how to build resilient infrastructure that doesn't just survive when centralized systems fail, but actually thrives. We're talking about maintaining complex interactions, settling transactions like chain cash, or, just texting your friends, all without a single cell tower.
To get there, we're going to construct this solution layer by layer. We'll start with the physical layer, look at edge intelligence, figure out how to bridge our mesh to the internet, address the notorious free rider problem, introduce Saito's economic engine, and wrap up with the ultimate decentralized stack.
All right, starting off with Layer 1, the physical layer, focusing on resilient off-grid communication. To actually get off the grid, we need a physical backbone. For this, we turn to Mestastic, which operates over LoRa radios. Think about centralized cell networks. They're incredibly fragile. If a single tower goes down, your smartphone is basically an expensive brick. But mesh networks are fundamentally different. They're completely decentralized. In a mesh, every single user's device acts as its own router, rebroadcasting the signal. If one node drops off, no problem. The network just heals itself and routes right around it.
And the sheer capability of Mestastic is just staggering. We're talking about running on super affordable low-power microcontrollers, like the ESP32. It uses LoRa, which stands for Long Range Radio Protocol, and because it transmits on license-free bands, literally anyone can use it. No ham radio license required. You'll typically get about 2 to 5 kilometers of range in a city environment, but the community record is a mind-blowing 331 kilometers line of sight. That gives us a massive, decentralized, physical layer with zero reliance on existing infrastructure. Moving right along to Layer 2, injecting some brains with edge intelligence using Gemma 4. A basic radio network is awesome for bouncing simple text messages around, but to build something truly powerful, we need intelligence. The absolutely crucial point here is Gemma 4's incredibly tiny memory footprint. Specifically, the E2B model, Edge 2 billion parameters, runs in under 1.5 gigabytes of memory. What does that mean for us? It means we can run frontier-level AI reasoning directly on a cheap, localized device without ever needing to ping a centralized cloud server.
And let's be clear, Gemma 4 is not just some basic chatbot. By adding this into our stack, our off-grid radios aren't just passively passing data. Gemma 4 handles advanced multi-step planning, native audio processing, and it has a massive 128K context window. Your offline mesh network can now run what we call agentic workflows. The AI becomes an independent agent. Imagine a node gathering local sensor data, making autonomous decisions, and coordinating a response entirely on its own, completely disconnected from the rest of the world. It's a total game changer.
Next up is Layer 3, bridging our local mesh back to the internet using MQTT. Having a sovereign off-grid network is fantastic, but eventually you want a way to link that isolated mesh to the broader world when a connection is actually available. We do this using MQTT, a lightweight messaging protocol. Say you have an ESP32 node sitting by your window connected to your home Wi-Fi. It acts as a gateway. This bidirectional bridge is exactly how we can integrate systems like Chain Cash or the Unified Payments Interface for off-grid financial settlement. Your local node can uplink mesh transactions to an internet broker, seamlessly syncing your offline financial activity with the global banking grid once connectivity is restored. But hold on, we have to talk about Layer 4, or rather, the biggest roadblock, the fatal economic flaw known as the free rider problem.
So we've designed this incredible network, right? But there's a catch. Think of it like that one roommate who streams movies in 4K all day but never chips in for the internet bill. In a decentralized network, somebody still has to pay for the hardware, the electricity, and the bandwidth to route all these messages and transactions. If it's just volunteers footing the bill, everyone else free rides. As the network grows, the data bloats, the volunteers go broke, and the system suffers a tragedy of the commons before ultimately collapsing back into centralization.
Which brings us to the solution in Section 5, Saito's economic engine, and the concept of routing work.
We simply cannot rely on charity to run a sovereign internet. Traditional blockchains have a major issue here, often called the infura problem, where they end up relying on centralized companies acting like exclusive toll booths because running a node is just too expensive. Saito completely flips the script. It's an open infrastructure layer that actually pays the access points directly for doing the heavy lifting. This makes it the absolute perfect settlement layer for an off-grid system like Chaincash, allowing it to operate securely without ever trusting a centralized server.
So how does it pull this off? Well, Saito uses a really brilliant consensus mechanism called routing work. When a node picks up a transaction from our mesh, it slaps a cryptographic signature on it to claim a portion of the fee. But here is the absolute genius part. As that transaction hops from node to node, its value for producing the next block goes down, while its cost to process goes up. This economic pressure forces nodes to rapidly share traffic rather than hoarding it. It completely solves the free rider problem, literally paying nodes to move the money data so Chaincash can reliably settle off-grid. As you can see, routing nodes are the literal backbone of the Saito network. By separating the payment for routing from the actual mining or staking, routing nodes get continuously compensated for the tangible, measurable value they provide to users. They are financially incentivized to keep the lights on and run the infrastructure our mesh desperately needs to survive.
Finally, Section 6. Bringing it all together into the ultimate decentralized stack. Now that we've stacked Meshtastic, Gemma 4, MQTT, and Saito, let's weigh the pros and cons presented in the source material. On the plus side, you get completely sovereign, highly resilient, off-grid communication. Because of Saito and Chaincash, it literally pays for its own upkeep, and thanks to Gemma 4, it has autonomous edge intelligence. But we do have to be real about the cons. The complexity is high. Combining radio hardware, local AI, MQTT brokers, and blockchain nodes is no walk in the park. Plus, that MQTT bridge does create a Wi-Fi dependency if your goal is to connect your isolated mesh back to global systems like UPI. But honestly, the underlying economic sustainability makes tackling that complexity totally worth it. David Launcher, Saito's co-founder, really hit the nail on the head with this quote. By aligning the economic incentives directly at the user-facing routing layer, this stack avoids those rich-get-richer dynamics that plague traditional systems. This right here is the missing key to decentralized technology that actually sustains itself instead of collapsing under its own weight. I'm going to leave you with that thought to chew on. We've just explored how integrating LoRa radios, edge AI, and economically aligned routing can build a network that's both brilliant and virtually indestructible. With our centralized infrastructure facing new stress tests every single day, figuring out how to connect, compute, and transact fully off the grid could very well be the most crucial technological shift we see in our lifetimes. Thank you so much for joining me on this explainer, and keep exploring.